drawing triple bonds, be sure to draw them in a straight line rather than zigzag. Means in this diagram, I have drawn it in zigzag manner, but the standard method. First of all, we will be discussing about bond line drawings. Actually, what happens, to do well in organic chemistry, first of all, you must first learn to interpret the drawings that organic chemistry or organic chemists use. When you see a drawing of molecule, it is absolutely critical that you can read all the information contained in that drawing, and without this skill, it will be impossible to master even the basic reactions and concepts. Therefore, this particular section is really very important here. For example, suppose I draw a very basic compound. Can you tell me how many carbon atoms are there? Can you tell me? Just try to count. Actually every corner of any ring represents carbon, right? So here, how many carbons can you count? 1, 2, 3, 4, 5 and 6. Here you can find that 6 carbon atoms are there. Okay, suppose I give you another example, that is of bond line. Suppose this is the example, right? Now I ask you that how many carbon atoms are there. So what happens, it is a common mistake done by the beginners that you forget that the ends of lines also represent carbon atoms. For example, in this diagram, can you tell me these are the ends? So are these carbons? Yeah, the ends also represent the carbons. These vertices, or you can say the V, also shows carbon. So how many carbons are there? If I do numbering 1, 2, 3, 4, 5 and this one, that is 6. So this is again the 6 carbons. So what the conclusion we read? That the vertex and the ends of lines show us what? Carbon. Okay. Now when any compound is given to you and you have to find that the double bond and triple bond. So how will you find it? I am going to discuss that case here. Let's see. This is any molecule. Can you point out that where is double bond? Yeah. This double line is the double bond. Now, if I ask you to mention the carbon, you will do just like this. So, how many carbon atoms are there? 5. And how many double bonds are there? That is 1. So, I can write that 2 lines drawn simultaneously upon each other represent double bond. Similarly, if the 3 lines are drawn just like this, these 3 bonds again represent the triple bond. So how many carbons are there? 1 carbon, 2 carbon, 3 carbon and 4 carbon. How many carbons are there? 4 carbons are there. And how many triple bonds are there? Only 1 triple bond is there. Now I would like to explain you one thing very important here, that when drawing triple bonds, be sure to draw them in a straight line rather than zigzag. Means in this diagram, I have drawn it in zigzag manner. But the standard method is this: whenever you draw triple bond, you should draw it in a straight line. Okay, if I give you example, suppose this is your molecule. Here triple bond comes. Now I ask you to calculate the carbon. So what the beginners will do? They will point out this carbon, this carbon, this carbon, this carbon. Is it it? No. You have missed the carbons, and in fact you have not missed a single carbon, you have missed two carbons. That is one here and one here. Because we know that triple bond is drawn in a straight line. So how many carbons are there? There are 6 carbons. Okay. And how many triple bonds are there? Only one triple bond. Actually, this thing is same as this thing. Okay. Or more correctly or more explanatory, if I draw it, it is same as this. You have to be careful for this thing. And I will tell you that you don't let triple bonds confuse you. The 2 carbons of the triple bond and the 2 carbons connected to them are drawn in a straight line. All other bonds are drawn as a zigzag line. Suppose for this, if I draw it like this, C, and then I draw triple bond just like this, it will be wrong method. Okay, what is the correct method? This is the only correct method to draw these. Now, if I give you some examples, suppose I give you this compound, this one, suppose this one, okay, this carbon here, this molecule here, now in all these molecules, you have to denote the carbons. First of all, I will suggest you that you should pause the video and first of all try this thing by yourself. Now let's discuss each and every structure one by one. Okay, so the very first structure, actually its name is important, benzene, that you will again and again read. So I will number the carbons, or I will point out the carbons for you. Here it is one carbon, here it is one carbon. You know that at the corners, at the vertex, there are carbons. So how many carbons you got? 6 carbons. How many double bonds are there? You see that here double bond is seen, here double bond is seen, and here double bond is seen. So how many double bonds are there? So double bonds are 3 in number, right? Now let's discuss the next case. So here what the thing is this, in this structure how many carbons are there? Let's see, this one, this one, this one, this one, this one, this one. So how many carbons? 6 carbons, because there are 6 vertices here, or you can say 6 corners are there. How many double bonds are there? So there is a single double bond here. Okay. Now let's move on to the next question. So the next question shows a structure here. You know that line end also represents a carbon. So these are line ends, these are your carbons. Fine. And you know that the carbons drawn on the vertices, that is the V, are also carbons. So how many carbons in total? 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10, 11. So 11 carbons are there. Are there any double bonds? No. So everything is saturated, means everything has a single bond. Okay. Now let's come on to the next question. So on the next question, we know that
in crowded classes, these gaps go unnoticed. With one-to-one mentoring, chemistry becomes logical and real improvement begins.